Hello, welcome to KAJOS Consultants. My name is Joshua, and today I'll be taking you through how you can test for normality. So normality is a property of random variable that is distributed according to the normal distribution. So for continuous data, the test for normality is an important step for deciding the measures of central tendencies, such as mean, median, and mode, and other statistical methods for data analysis. There are two ways of testing for normality in SPSS. One is by using the SPSS explore function, and the other way is by running multiple regression analysis. When you are testing for normality using the explore SPSS function, then you have to check mostly on the values that will be presented on the significance level of each variable. When you find that your variables are statistically significant, then it means the assumption of there is no normal distribution. And if you find that the values are not statistically significant, meaning that the null hypothesis is upheld, then there is a normal distribution for such data. So let me take you to where my SPSS data is. So this is the data that we are going to use for this particular activity. So to run or to check or to test for normality, simply place your cursor on the Analyze menu on the SPSS main menu and click on Analyze, then on Descriptive Statistics, then on Descriptive Statistics, then on Explore. Then click on Explore. Once you click on Explore, we'll have the variable that we want to test. And for this case, we can simply pick maybe these two, or compensation and job recognition, then move to the dependent list. Then we can check on statistics. We can go with descriptives, check that. It is also checked by default. Then plots, you have a normality. Then you can also have the histogram. We can uncheck that, then continue. Then under options, can just leave it that way. Then we click on OK. So, and give it time to run for this to be generated. So our interest will be on this table where we have test of normality, and also with the specific concern or interest on Kolmogorov, Smirnov, and Shapiro Wilk test for normality. So if you check at the significant level, you find that all the values are significant, whether you do the test the normality through Kolmogorov, Smirnov, or Shapiro Wilk. So you find all our values here are significant, meaning that these values or this variable or what we are testing here for the normality section, there was no normal distribution for this data because all our variables was statistically significant. Another way you can check this is by having an histogram, and this can normally be well explained when you do multiple regression. So let me just close this. Can do another one, analyze, then go to regression, then linear, and then you have our dependent. So total is going to be our dependent there. Then we have compensation, these two, use as independent variables. Statistics part, we can leave it the way it is. Then plots. So plots, we can do normal distribution or test for normality by checking on the histogram and normal probability plot. Then on the Z predictor, you have it on the x-axis. Then on the residual, you have it on the y-axis there. Then we click on continue, then click on OK. So if we click on OK, then we come and check on the histogram. So when checking for normality on the histogram, you have two ways of doing this. You have either checking on the histogram and also checking on the normal PP plots that we have. So for the histogram, the graph or the curve have to be bell-shaped symmetry. So it has to be bell-shaped with the maximum values being in the middle of the graph or of the curve and minimum values lying outside. So if we check at this graph, we find out that our maximum, the curve, is not capturing the maximum values inside it. We find that there are maximum values lying outside the curve. So meaning that this is there's no normal distribution for this. And then this does not obey the rule of the assumption of normality. You can also check the normal PP plots. And this one normally focus on the straight diagonal line that cuts this or cuts across this. And then the plots or the values that we have should be lying closely on the line. Most of the plots that we have should lie on this line. So for this case, you can arrive at the conclusion that the study or this research did not obey the assumption of the normality because most of the plots are not lying on the straight diagonal line. So this marks the end of testing for normality. At that point, kindly click on the subscription tab below to subscribe to this channel so that you can be finding more of these updates.